All right, so hopefully the quiz wasn't too bad. There's a lot of math. I was just trying to do the answer key. I mean, there's a lot of different parts and whatever, but they're all pretty similar to each other. So hopefully we'll have those graded today, and then we'll go over them tomorrow just real quickly. And yeah, you can watch the review of that on this exciting videos that we always have. All right, so what I want to do today now is cover other ways of measuring concentration. Other ways to measure concentration. And then we're going to convert between those. Now this will not be on the AP test. Therefore, I'm only going to go over it quickly one time. I will give you some other practice problems if you want to do that, but this will be a bonus on the next test. Okay? So, we've already got the one that we did was molarity. We already know this. So this isn't really an other way. This is just a review. And we know that molarity is equal to what over what? Moles over liters. Moles of solute. And this is where it's going to be important, where we really keep track, over liters of solution. Okay? So we already know that one. Capital M. The second one is molality. And it's really an italicized M. I can't draw an italicized M, but it's an italicized M is what we use for molality. Now, the only time that I know that molality is used is in freezing point depression and boiling point elevation problems. When you try to figure out how much, when you put salt into water, how much it lowers the freezing point. There's that equation. It is used, but it's going to be moles of solute, just like molarity, but this is going to be kilograms of solvent. So this is the total volume of the solution for molarity, where molality we just change and do kilograms of solvent. So you have to know exactly how much water or whatever you're going to add to it in terms of mass. Okay? The third one is mass percent, which is just going to be that, which obviously is going to be, what do you think, what over what? What's on top?
Mass of solute.
Mass of solute over mass of solution. We multiply it by 100 to get to percent. Now, have y'all ever heard of ppms, parts per million? Heard things measured in concentration in terms of parts per million? You would do the exact same thing here, except you multiply by 1,000,000 instead of 100 to get ppms. Nowadays, they're doing parts per billion and even sometimes parts per trillion because our measuring devices have gotten so much better. Okay. Then you have to balance out. Okay, so if there's mercury in a system at parts per trillion, yeah, we detected it, but is it really bad for you at those very low concentrations? So there's the battle between risk reward. Does everything have to be actually zero in order to be okay? And then lastly is mole fraction. And I don't know where this comes from, but they use the letter X to represent mole fraction. What do you think this is?
Solute over moles.
Moles of solute over total moles. Okay, and it's a fraction, so we don't multiply this one by 100. Now, total moles is going to be moles of solute plus moles of solvent. Total moles. Okay? So solute over solute plus solvent. So these are the 4 ways we can measure concentration. So if we want to go through then and say, okay, well, how do I calculate these individually, but then how do I convert between, you know, if I know the molality, can I find the molarity or the mass percent? You know, if I know one, can I know the other ones? And based upon that question, what do you think the answer is? The answer would be a yes. Okay? I gotta put glasses on to be able to read, which problem I want to do. Should have turned on. All right. Take them more when I put my glasses on. There we go. Just don't. Okay, I am on page 160 in the textbook. Seriously? Okay. Well, textbook had a good problem. Put it in, and I'll post this worksheet online for you. Okay, so when we look at like number 23 right here. It says, hydrochloric acid is sold as concentrated aqueous solution. If the molarity of the commercial HCl is 12.0 and its density is this, calculate the molality and the weight percent. Weight percent and mass percent are the same. What do I do with my shield? On camera. Oh, there it is. Gotta be safe. All right, so the molality of the solution. First thing we want to do is say molality is moles of solute over kilograms of solvent. Okay? Now, what does this 12.0 molar, it says the molarity is 12.0 molar. What does that really tell me? There's 12 moles of solute for every 1 liter of solution. Right? So I know that. So what do I know is here's my unknown. I want to find this. What do I already know? Moles of solute. Because that's not going to change. I mean, I'm measuring the same thing, 12 moles of HCl. Divided by then I need to find kilograms of solvent. Well, this is the tricky part. This is the hard part. Well, I know how much solution do I have if it's 12 molar. 1 liter. So we need to figure out not just mass of the solution, but the mass of the solvent here. So how do I go from liters to grams? What's my conversion factor always between liters and grams, or mass and volume?
1 milliliter is 1 centimeter cubed.
That's a pure water only.
Oh.
I mean, that's true. Well, let me say that. That's true as far as 1 milliliter equals 1 cubic centimeter always, but for water, the density is 1, so that means that, 1 liter would be 1,000 grams. But this is impure, so what's the conversion factor that we use to go from grams to grams to liters or milliliters. What else is given in the problem? So what? The density. What are the units on density? Grams per centimeters cubed, right? So I can say then that 1 liter we know is 1,000 cubic centimeters of solution. I'm just going to say apostrophe then. Okay? Times 1.18 grams per cubic centimeter. So that means that my solution weighs 1,180 grams. Right? But what do we need? The solvent. So what's the solution made up of? 2 things, what? The solute and the solvent. Do we know anything? We need the mass of the solvent. This is equal to the mass of solute plus the mass of solvent. So, what do I do? The mass of the HCl, so I'm going to say 12 moles HCl times the molar mass, which is going to be 35.45, 36.46. Someone, well, I have calculators here. 12 times 36.46 equals 437.52. So I have 1,180 grams of solute. That's going to equal, so 1,180 grams of solution, is going to equal 437.52 grams of HCl, the solute, plus the mass of the solvent. So I just subtract. And you get 742.48. Which is equal to how many kilograms?
0.742.
Right. We do it 3 places. All right, well, we're still not quite done, because now I need to come and take this number and put it back into my original. So I'm going to say 0.74248 kilograms of, in this case it's water. So 12 divided by 0.74. This doesn't have a second function answer. I get 16.16 or 16.2. Hey. Yeah. Give me in 20 minutes I'll be done. What is that?
I was just gonna stay in Canadian.
Oh, okay.
There's just one of the ones that I thought they were on Tuesday.
We are.
Just trying to say my.
Mine say 5 through 7, 5-7.
But we don't have Wednesday. We have Thursday.
I know, but we have it Monday, Tuesday, Wednesday for that week.
Okay. So, but we do have it Tuesday.
Yeah.
Because I just put Monday, Tuesday.
Okay, that's fine.
Okay.
Okay. The key on this part is using the density, and you have to differentiate between the mass of the solution and the mass of the solvent. Always note, when they give you the density, it's of the solution, but you need the mass of the solvent. Sometimes we'll go the other direction, and you know the mass, you have to figure out the mass of the solvent, And then, you know, you get the total mass of the solution by adding the two together. Then you have to use the density to go what would be the volume of the solution for molarity. Okay? So for molarity to molality, since we're going from liters to grams or kilograms, the density is going to be the key there. And knowing mass of the solute and mass of solvent equals the mass of the solution. Okay? Now to do the other part is pretty simple. Okay? I'm just going to do it right off of this right here because I'm out of board space. Okay? But I already know now the mass of the solute, right? We figured that to be 437.52 grams of HCl. We already know the mass of the solution. We did that, 1180. Right? Times 100, and that gives me my percent. Or 37.5 divided by 1180. And I get 0.371, or 37.1%. Okay, that's a saturated solution of HCl in water. That's the most concentrated you can get an HCl solution. Is 37.1, which is 12 molar, or 16.2 molal. Now, well, how could I find mole fraction? The question didn't ask for that, but if I wanted to do mole fraction, what would I have to find? Do I know how many moles of solute I have? 12. Divided by total moles, which is moles of solute and moles of solvent, so it's 12 plus, what do we need to know? The moles of solvent, which is water, which we know to be this many grams, right? So how do we find out how many moles that is? Just divide by 18. So 742.48 divided by 18.02 is equal to, that's not right. Try that again. 742.48 divided by 18.02 equals 41.2 moles. So that turns out to be then 12 divided by 53.2 is 0.226. And there's no unit on mole fraction. So we would say this is equal to the mole fraction of HCl. If you wanted the mole fraction of the solvent, you would just put the moles of solvent on top, divided by total moles. Most of the time we do it as solute. Okay? So it's just going to be a lot of conversions between grams and moles and liters and grams and liters. Okay? So the density, in order to be able to go from molality and molarity, almost always you're going to be given the density. Okay? Let's look at another one. Does everybody have this all down that needs it? And again, I'll post this worksheet in Classroom just so you have copies of the questions. I shouldn't have erased all that. Oh well. Let's go. All right. So this one says, that concentrated sulfuric acid has a density, notice they give you the density, and a 95% by weight H2SO4. So this is my given right here. What is the molality? What is the molarity? So what does 95% H2SO4 really mean? That's mass percent, but what do I know from this?
So the mass solute for the mass solution times 100 equals that.
Equals that. So how much solute do I have? 95 grams. Because it doesn't tell you, I mean, the solution is homogeneous, so it doesn't matter how much. So we're just going to assume, well, let's just say we have 100 grams. So then that means that I have how many grams of solution? 100 grams of solution. Now, simple math, of that 100 grams, how much is H2SO4? 95, right? Which leaves 5 grams to be, you always assume the solvent is water, so just 5 grams of water. So it really means that I have 95 grams of H2SO4. I have 95 grams plus 5 grams of water. That's everything that I can figure out just but from this. Okay? So we need to know, again, a mass percent that you have, okay, this is what I know. Okay? So now to do the rest, to do molality is equal to moles of solute, in this case H2SO4. Let's just do that, H2SO4. Over kilograms of water. Now, do I know either one of these things already? What do I know, Ben? I know kilograms of water. I know 5 grams of water. So I just move it 3 places. So I know that I have 0.00500 kilograms of water. So I have to find moles of H2SO4. So how do I do that? Math. Yes. Can we narrow that down a little bit? Say what, Anna? The molar mass of the H2SO4, which turns out to be 98.1 grams. So I'm just going to say, I'm going to do it on top here, 95 grams times 1 mole over 98.1 grams. So what's 95 divided by 98.95 divided by 98.1 is equal to 0.968. Divided by 0.00500 kilograms of water. I get 193.7 molality. Just out of curiosity, is this showing up on the screen?
Yeah, it is.
Okay. Thank you. My video directors. Okay, so again, the key is what do I know from the given, and then I just have to convert that to the appropriate units using the other given and what we know. So then to go to molarity is equal to moles of H2SO4 over liters of solution. So I know moles of H2SO4 now is 0.968. How do I get liters of solution? What haven't we used yet? The density. Again, what do we know about the solution? It's 100 grams, right? Well, how do we use, what's the conversion factor between grams and volume? It's going to be the density. Okay? So I know that I have 100 grams of solution, and I know that the density is equal to 1.84, so I'm gonna say 1 cubic centimeter over 1.84 grams. And I need liters, so I'll go ahead and just do, you can do it in your head or this way, 1 liter over 1,000 cubic centimeters. Hundred divided by 1.84 divided by 1,000. Counting out a bunch of numbers. 100 divided by 1.84. Okay, so that's 54.3 cubic centimeters, so it's going to equal 0.0543 liters of solution. So I put that up into here. And we end up getting 0.968 divided by 0.0543 equals 17.8 molar. Notice the big difference between molality and molarity. Molarity is the one we use because it tells us moles per liter, and it's the easiest one, which you just did on the quiz. It's the easiest one to figure out if I have 100 milliliters of a solution, well, how many moles of the solute do I really have in there, because that's what I need to know in terms of a reaction. Okay, now we could do mass percent from this, doesn't ask for it, but mass percent would be mass of solute, which we know to be, how much? Actually, we have mass percent there, as it's given. Okay, well, let's do, if we did mole fraction, then we know how many moles of solute we have, and then we just need to figure out how many moles of solvent we would have by dividing by 18. Add those two together, that's your denominator. Okay? So the whole key is using the density to convert. Notice this time I'm giving grams of solution, I have to figure out liters of solution. Okay? Sometimes they might just tell you grams of solvent. And you have to then, knowing that. So, what do you got? 5 minutes? Let's see what you can do in 5 minutes. Number 25. Again, this will be posted online, but those of you watching it online, you can always just pause the video and you can see the problem. I'm going to go ahead and stop the video now. We have 5 minutes left in class. Let's just see if we can have this for tomorrow. We'll go over it first thing tomorrow.
Is the solvent always water?